Time to write more electron configurations for transition metal cations. This time, we're going to remove 3 electrons from each of these neutral atoms to get the 3 positive cations. Chromium is actually an exception to the Aufbau rule, but it's not going to matter because we're going to end up removing 3 electrons. So chromium, if you notice, it ends in this first, second, third, fourth position in the 3D block. So we can write the electron configuration for the neutral chromium atom by going back to the nearest noble gas, which is argon. Put that in brackets. That covers the first 18 electrons and write whatever is remaining, which is your 4s block, which is filled with 2 electrons, and then the 3d block, and it's the 4th position, so it's going to end there. Now again, this is an exception, so in reality, this one of these guys is going to get promoted here, but it's not going to matter. So actually, I'll write them both out. So the true electron configuration is 4s1, 3d5, and it does that. Some teachers will say because it'll give that sublevel a half full electrons, where you have 1 electron in each of the d orbitals, and they're all spinning parallel. So they get that stability at the expense of one of the s orbitals, but I'm not sure if that's a thing that we know for certain. I think we're still looking into that and maybe debating that. But anyway, if that helps you remember some of these exceptions, because it happens a lot. All right, any case, we need to remove 3 electrons. So it didn't matter because we're moving both those electrons in the s orbital, or one of these in the s orbital. And if you remove 2 from the s, you're going to have to remove 1 more from there, and you'll get 3. If you remove 1 from the s, you're going to have to remove 2 from there, and you still get 3. So that's why I was saying it's not going to matter, because what you get is argon 3d3. And that's your electron configuration for the chromium 3 positive cation. All right, let's move on to manganese, which is right next to it. So all right, let's just do this one, showing the steps. So manganese, it has the same previous noble gas, it's argon, and we're going to get through the 4s by filling that up, and then it's in the 5th position on the 3D block, so 3d5. Now we're going to remove 3 electrons. So again, the first 2 electrons are removed from the highest end first. That means usually s's get removed before the d's, and we need to remove 1 more, so that'll turn that into a 4. So the electron configuration for the manganese 3 plus cation is going to be argon, and then 3d4. All right, and finally, let's see. Let's go to iron. So we don't need to do all of this again. You know we're going to remove 2 from the s and 1 from the d. So iron is over there, number 26. So the 3 plus cation is going to have the electron configuration of argon. And then you know that section is going to be removed, and then one of these guys is going to get removed. So it's going to be 3d5. All right, so if you miss that, the regular ion, or the regular electron configuration for iron, is that, but when you remove, oh, forgot the 2. But when you remove, you don't remove the last one you filled, so you don't do that. That's wrong. You remove from the highest principal quantum number, the highest n, so you move 2 of those, and then you can start removing from the d's. And so there you get 3d5.